Good afternoon. My name is Yuan Li, a third-year PhD student from Virginia Tech, advised by Dr. Doug Bowman. It is my pleasure to present my planned research dissertation focusing on exploring spatial referencing for anywhere, anytime augmented reality. Let's start with some typical examples of AR-assisted collaboration. Here, the AR users are inspecting architecture model together. One key component in their collaboration is that one of the users is referencing to a feature of the model to guide the attention of the other users. The same action plays an equivalently important role when the target location exceeds the user's arm reach. And even when the collaborators are separated, referencing a location or a target of interest in space can still be crucial. In this case, a remote expert gives instruction by referencing a particular part on the machine to help a local worker. Their actions can be described as spatial referencing, the communication and confirmation of a location in space. Imagine we could expand this into our daily life with augmented reality, where the users have the ability to reference to any location, any target, any content, unconstrained from space and time. This will open door to a variety of social applications that could potentially change people's life. And of course, there is a long way before we reach that point. The focus of this dissertation is to tackle a subset of the major challenges involved. First, in order for the AR system to indicate the referenced location, it has to have some knowledge of that location in the first place. Normally, this requires a reliable model of the environment and sometimes even reliable model of the referencing tool. However, the world is rapidly changing, and it is difficult to obtain a reliable and up-to-date model all the time. And what we can do to overcome this problem. Another challenge brought by the collaborative activity's nature is the tracking and among-user alignment issues. Both could severely reduce the spatial referencing accuracy, therefore affect overall performance. How can we mitigate the errors to ensure usable spatial referencing independent of space and time? I propose a research agenda consists of 5 projects in the hope to address these challenges. The first project is about point marking. Why does this matter? In an outdoor environment, if we don't have a geometric model of the environment at all for spatial referencing, one approach is to create our own referenced point. This could be especially beneficial for mobile AR applications, such as CAD in the field. We designed multiple geometric point marking techniques that tries to improve the accuracy and precision of the created reference point. These techniques are evaluated in AR simulation and outdoor AR setup. The idea is to use 2 rays in space to mark the target as their intersection. Now, the performance of this technique largely depends on how well the rays are defined. We propose 2 techniques. The upper one uses multiple samples to attenuate the errors from single ray, while the other one completely decouples the definition of rays from physiological movement of the user. Our work proves that it is possible to create a robust reference point. The detail of this work can be found in our paper. The second project shares a similar assumption as Project 1. If we don't have a geometric model of the environment at all for spatial referencing, what can we do to help convey the referenced target through visualization? This is relevant to outdoor collaboration tasks, where users are not close to each other, such as geographical scientists in the field. We designed and evaluated gaze ray visualizations that help eliminating possible ambiguity. Here is a simple illustration of a direct use of AR ray in model-free outdoor setup. The virtual ray will appear to be overlay everything in the observer's view and therefore missing essential depth cues to convey spatial referencing. We propose two enhancements to the single gaze ray. The double ray technique, which visually brackets the target and eliminates confusion. The parallel bar technique, which provides artificial orientation cue to the ray to help user perceive better. And one thing to note, in its more ecologically valid setup in outdoor AR, we also explore how to align co-locate but distant users for sharing AR content. Our work proves that this problem can be attenuated with carefully designed visualization techniques. Detail of the work can also be found in our paper. The third ongoing project still assumes there is no reliable model, but this time the missing model is the user's hand. When the users are close, as illustrated earlier in this presentation, it is almost instinction for the user to reference a target with their bare hand. If the AR device does not have tracking of the user's hand position and orientation, there will be no occlusion cues that the system can provide to the observer. How will this impact on the referencing task? This project aims to study the effect of occlusion cue and provides quantifiable results of its influence and is currently only focusing on evaluation. We compare the accuracy and task completion time with or without occlusion cues and different spatial relation between the targets and collaborators. While the difference is predictable, it is interesting to observe how users take different strategies to improve their performance. The work is still currently ongoing and will be submitted in short time. The next project on the agenda is to include unreliable model. In reality, we can still obtain models that are not perfect. How much could they help? The goal for this project is to revisit previous projects to seek for improvement. At last, we take a shift in focus to emphasize on the second challenge of mitigating tracking errors and improving alignment for spatial referencing in everywhere. One of the potential solutions is crowdsourcing, where users are provided the interface to refine, reference the location relative to the real world, and use global knowledge to increase overall performance. Thank you so much.